table. I have drawn a table here, and I'm taking equal amount of dilute HCl, sodium hydroxide, and water in 3 different test tubes. And I'm adding red litmus paper and blue litmus paper to find the nature of the solution. So, in dilute HCl, I could understand that blue litmus paper changes to red. In sodium hydroxide, red changes to blue. Whereas in water, there is no color change. There is no color change. So when the litmus paper, the blue litmus paper changed to red, it is understood that the nature of the solution is acidic. When the solution red litmus turns to blue, we can understand that it is basic. And in water, there is no color change. So there is a neutral solution. Neutral solution. So using indicators, we are able to find out. So the litmus paper also we can take as an indicator which shows that whether the solution is acidic, basic or neutral. So water is a neutral solid. So we all know that acids are those substances which are increasing the concentration of H plus ions in the solution, whereas bases are those substances which are increasing the concentration of OH minus ions. Now, to find out the acidic and basic solutions or acidic and alkaline substances, there is a scientific method. So we are going to discuss about that. Now this is a pH scale. The pH scale is actually put forward by Sorensen. Okay, Sorensen. He is a Danish scientist. So this method was used to find out acidic and alkaline substances. It is a scale ranging from 0 to 40. So from 0 to 7 it is acidity, and from 8 to 14 it is alkaline, and 7 is neutral. Okay, so as we go from 0 to 6, from here 0, 1, 2, 3, acidity is more. Okay, more. But when we go towards the neutral side, that is 5, 6, etc., acidity is decreasing. That is from 0 to 3, acidity is greater, it's more. But when we come closer to the neutral solution, the acidity decreases. Now from here, when we go to 8 to 14, alkaline nature is increasing. That is 12, 13, 14, etc., alkaline nature is more. So with the help of the pH meter, we are able to find out the reading, whether it is acidic, or in the pH meter it will be shown, whether the reading will be shown whether it is 4 or 5 or 10 or 11 or 14 or 7. So from these readings we are able to identify whether the given solution is acidic or alkaline.
We have to do with solutions in the laboratory? Or does it also affect plants and humans in daily life? Did you know that when acid rain flows into the rivers, the overall pH of the water reduces? And living organisms cannot survive if the change in pH is too much. In such cases, survival of aquatic animals becomes difficult. What about survival of plants? What's the most important factor for the healthy growth of a plant? Yes, it's the soil. Plants require a specific pH of the soil for healthy growth. Plants cannot grow if the soil is too alkaline or too acidic. So if the soil is too acidic, its pH can be raised by adding lime, which neutralizes the excess acid in the soil. Similarly, if the soil is too alkaline, then its pH can be lowered by adding gypsum or some other substance which can neutralize the excess alkali present in the soil. And does it affect us too? By now, you should know that our stomach produces hydrochloric acid which helps in digestion. Sometimes, if too much acid is produced, it causes pain and irritation. It can even cause ulcers. In order to treat this hyperacidity, a patient is advised to take antacid tablets or antacid suspensions. And these antacids neutralize the excess acid. Magnesium hydroxide, a mild base, is often used for this purpose. And the reaction looks something like this. The acid is neutralized to get salt and water. What about the pH in our mouth? Yes, the pH in our mouth also has an effect on our teeth. Tooth enamel is the hardest substance in our body and does not dissolve in water and mildly acidic solutions. However, it gets corroded slowly when the pH in the mouth falls below 5.5. But how does the pH fall below 5.5? When we eat food, some food particles remain stuck to the teeth. Bacteria present in the mouth produce acid by the degradation of the sugar and food particles present in the mouth. This is what causes decaying of the teeth. What's the best way to avoid this? We should clean our mouth after eating food. And something even better would be to avoid eating sugary foods. Cleaning the teeth using toothpastes help in preventing tooth decay. Toothpastes are generally basic and hence they neutralize the excess acid in the mouth and prevent tooth decay. The concept of pH also helps in understanding the self-defense used by certain animals and plants. If you've ever been stung by a honeybee, do you know what really caused that acute pain? Yes, it's the acid in that sting which caused the pain. So if we use a mild base like baking soda around the stung area, it gives us some relief. And in nature, there are leaves which have stinging hair and they inject acid upon touching them. Again, we use something which is basic in nature to get some relief. So these were some of the ways in which the concept of pH is used in daily life. In the coming videos, we will understand more about salts.
Now when we are studying about, now we are continuing another topic, that is pH scale. Now this pH also has a wide influence in our daily life because this also helps us to find out whether it is acidic or basic. Now if a person who is doing some agricultural, if he is a person who is working in agricultural fields and whatever seeds he is sowing, it is not coming up nicely. So what he will do? He will go to, he will take his soil. So he will understand there is some problem with my soil. That is the reason why I am not able to get a good harvest. He will collect some soil. He will go to a soil testing lab. He will give that sample of soil to them. They will test it and they will say that, sometimes they will say that the soil is acidic. Sometimes they will say that soil is basic, alkaline in nature. So using the pH, they are able to identify whether the soil is acidic or basic. So if the soil is acidic, they will be giving slacked lime to neutralize it, to make it a controlled way. If it is basic or if it is alkaline, they will be giving some other substances or acidic substances to neutralize it. So pH, actually a pH meter. Now in modern use, usually we were having pH papers, but now we are using pH meter, which helps us to find out whether very quickly, within a span of time, we are able to identify whether the pH of the solution, and using the pH we can identify whether the solution is acidic or basic. Here I am taking HCl. This is an acid. I am taking Na. Okay, NaOH and HCl. This is a base. So I am going to find out what are the products which are obtained. Here, this hydrogen combines with this OH to form water, and Na and Cl combines to form NaC. This is a salt. Isn't it? This is a salt. So whenever an acid and a base reacts, it gives us salt and water. Now, in sodium hydroxide, which is the positive ion? Sodium is the positive ion. In hydrochloric acid, which is the positive ion and negative ion, hydrogen ion is a positive ion and chlorine is a negative ion. So this positive ion, that is sodium, and the negative ion, chlorine, combines to give us NaCl. So this is a salt, I told you. So a salt consists of a positive ion and a negative ion. Okay, this is the common salt. Okay, so when sodium chloride is a salt which is produced by the reaction between an acid and a base. So you know what is the name of the reaction? Yes, neutralization reaction. And there's one more thing, that the salts, they are ionic compounds. They are ionic compounds. Salts are ionic compounds. Now I am giving you another equation. Here I am taking another base, that is magnesium hydroxide, and a base, an acid, that is sulfuric acid. Okay, so this magnesium is a positive ion and sulfate is a negative ion, you know. So this magnesium and sulfate combines to give us magnesium sulfate and water. Magnesium sulfate and water. Okay, now here there is magnesium chloride. So from this salt itself, we can identify what is the acid and base involved in this formation. So the acid will be actually HCl. Okay, and what is the base or alkali which is formed with magnesium? Yes, magnesium hydroxide. Now calcium sulfate. Okay, calcium sulfate. In calcium sulfate, the acid will be acid containing sulfate. So which type of acid it will be? Yes, sulfuric acid, and the alkali will be calcium hydroxide. Now aluminium sulfate, Al2SO4 thrice, which is the acid here. When sulfate comes, the acid will be H2SO4, and the base will be, base or alkali will be aluminium hydroxide. Now NaNO3, sodium nitrate. When nitrate comes, what is the acid we formed with nitrate? Yes, nitric acid, HNO3 plus Na. Okay, so from the salt itself we can easily identify the acid and the base. It is the acid and this is the alkali. Okay, so in the text, in your text it is given the names of some positive and negative ions are given in your text. To study them, you have to by heart them completely. Then only we will be able to write the chemical formula of some salt. Okay, now there is a table of positive ions and negative ions. And using this positive ion and negative ion, we are going to find out or write the formula, chemical formula of some compounds. But first I am taking calcium and chlorine. Okay, so calcium I am writing here, chlorine here. Okay, so calcium is 2 plus, chloride is Cl minus. You don't need of writing the charge, you can just write 2 and 1 here. 2 and 1 here. Cross multiply, we will get CaCl. Now I am taking calcium and sulfate. Ca, here it is 2. Sulfate SO4 2. Cross multiply. Don't write the charges. Okay. Ca2SO4. Since 2, isn't it? It is like this. Since both of them are having the same number, it can be easily divided by 2. So what will be getting? CaSO4. Calcium sulfate. Next one, calcium and phosphate. Ca2 and PO4 3. Cross multiply. You will get Ca3. This phosphate ion is a radical. Okay, so we will be putting it as Ca3 PO4 twice. Cross multiply. Just cross multiply it. That's it. Next, it is ammonia. Ammonia. It is only one positive charge. So you can write one here. And chloride, one minus charge. And you get, when you cross multiply it, you will get NH4Cl, ammonium chloride. Next, ammonium ion. This charge is 1. Sulfate, charge is 2. This cross multiply, you will get NH4 twice. If the number is more than 1, you will have to put it in the bracket. NH4 twice. So 4. So if you have to write or find out the formula, chemical formula of such salt, first what you have to do is that you have to study the charges which is given. There is a table in your textbook where there is a table of positive ions and negative ions. You have to by heart that. Then only you will be able to find out the chemical formula of the salt.